Hi everyone! In this video we're going to talk about applying linear equations. So the learning goal is we are learning to solve equations and interpret solutions in a context. So let's take a look at example number 1. Pam and Rachel buy books at the bookstore where Rachel works. As an employee, Rachel pays only 75% of the advertised price. How many books could each purchase and spend the same amount for the same number of books? So let's take a look at the picture. You have Pam and Rachel. The girl on the left, she bought books at a book fair for $4 each. $4 each. And used a $5 off coupon. Okay. This second girl in pink, I bought books at the bookstore where I work. So this must be Rachel. And this is Pam. So she buys the books for $8 each and used a $4 off coupon. Question number 1 says, complete the equation to represent Rachel and Pam buying X books. So we're going to let X equal the number of books. And they're going to pay the same amount. Let's read the question again. Pam and Rachel buy books at the bookstore where Rachel works. As an employee, Rachel pays only 75% of the advertised price. How many books could each person purchase and spend the same amount for the same number of books? So what's happening here? They're both buying the same number of books, whether they both buy 4 books, 5 books, and they're spending the same amount. What does that mean algebraically if they're spending the same amount? Well, right here. It means they're equal. Whatever Rachel pays, that's going to equal whatever Pam pays. So we need to write expressions for both Rachel and Pam. So I've started the equation off here for you. Okay, this 75 hundredths, what does that represent? Well, that's the percentage that Rachel pays because she works at the bookstore. She gets a pretty good discount. If she pays 75%, that means her employee discount is 25% off, meaning she pays the other 75%. So if Rachel works at the bookstore, she pays $8 each book. How do I represent $8 each book? 8x, and she gets $4 off. So we're going to take away $4. Okay? So let's read that expression again. She pays 75% of $8 a book, take away $4. That's her coupon. Okay. Now let's do Pam. Pam spends $4 a book, but has a coupon for $5 off. How would I write that? $4 per book, take off the $5 coupon. $5 off. Here is your equation to represent how many books they're buying, X, and they have to pay the same amount, so they need to be equal. Whenever you want something to be the same, it's going to be equal. So question 2 says, let's solve this equation. So I'm going to rewrite 4x minus 5 equals 75 hundredths times the quantity of 8x minus 4. So let's solve the equation. Let's simplify it by distributing. 75 hundredths times 8x is 6x minus 75 hundredths times 4 is 3. Bring everything else down. Let's bring our like terms together by doing the inverse. So I'm left with negative 5 is equal to 2x minus 3. Now let's bring the constants together by adding 3. So I'm left with 2x is equal to negative 2, which means that x is equal to what? Negative 1. x is equal to -1. And what did x represent? The number of books. That's weird. Question 3 says, is it possible for Sam and Rachel to each purchase X books and pay the same amount? Can you buy -1 books? No, you can't. That's not possible. You can't have negative books, just like you can't have a negative distance. So this is actually a no solution problem. There is no number of books that Pam and Rachel can buy and spend the same amount. Let's try another one. Number 2, James rides down in an elevator that starts at a height of 120 feet. Brianne rides up the stairs from the ground floor. All right, let's look at the picture. Here's James, and he is 120 feet up. He's going down, while Brianne is down at the ground floor. Ground floor is 0, and she's going up the stairs from the ground floor. So they're getting closer to each other. As James goes down, Brianne goes up. Use the equation 120 minus 2.5t, or 2 5/10 t, equals 1 5/10 t to represent when James and Brianne are at the same height after t seconds. So at the same height means when will they be equal to each other? As James is going down and Brianne is going up, when will they equal? When will their heights equal after t seconds? So t is equal to seconds. So they've given us the equation, so let's go ahead and solve. Oops. So we're going to bring the variable terms together by adding 2 and 5/10 t. So 120 equals 1 and 5/10 t plus 2 and 5/10 t is 4t. Divide both sides by 4. T is equal to 30. 30 what? Go back to your variable. 30 seconds. That means after 30 seconds, they will be equal. So James goes down the elevator, Brianne goes up the stairs, and after 30 seconds, they're in the same spot. What does the solution represent about James and Brianne's location? They will be at the same height at 30 seconds. 30 seconds for them to meet up. What is their height above the ground floor when they are the same height? So after 30 seconds, where are they meeting? James is going down and Brianne is going up. And after 30 seconds, where are they? Well, let's take our original equation and plug in our time. Our time is 30 seconds. So 120 minus 2 and 5/10 times 30 seconds is equal to 1 and 5/10 times 30 seconds. And let's figure out where are they on the stairs / elevator. What's their height? 2 and 5/10 times 30 is 75. And 1 and 5/10 times 30 is 45. 120 minus 75 is 45 equals 45. So at 30 seconds, their height is 45 feet. 45 feet above ground floor. That's where they are meeting. And that's it. The next example. A scientist conducts an experiment with 2 trees over many years. The shorter tree has fertilizer applied to it, and the taller tree does not. The shorter tree grows at an average rate of 8 inches per year. The taller tree grows at an average rate of 6 inches per year. Write an equation to represent the trees having the same height after t years. So t is equal to the number of years. Let's put number. So So the shorter tree has a rate of 8 per year, and the taller tree has 6 inches per year. So let's write an equation. How could we represent the smaller tree? Well, the smaller tree is starting at a height of 50 inches, but we're adding inches at a rate of 8 inches per year. Remember, per means multiply. Whereas the taller tree is starting off at 70 inches, but grows, gets bigger at a rate of 6 inches per year. We want to know, when will those be the same height? So let's solve this equation. Let's bring our constants together. 8x is equal to 20 plus 6x. Bring our variable terms together. So x is equal to 10 inches. Oh, no. I'm sorry. Not 10 inches. 10 years, right? Go back, make sure. This is why it's important to write out what your variable stands for. 10 years. Okay? So in 10 years, they will be the same height. What will be their height when they are the same? Oops, look, we skipped this one. 10 years. After how many years will the heights be the same? 10 years. And in 10 years, what will that height be? Well, let me scroll up. After how many years will the heights be equal? So we're going to just take our 10 and substitute it in. So 50 plus 8 times 10 equals 70 plus 6 times 10. 8 times 10 is 80, and 80 plus 50 is 130. And let's just double check. 70 plus 60 is indeed 130 as well. So after 10 years, the two trees will be 130 inches tall. Oh, look at that red E. Okay. So we're writing our equation, solving our equation, and then substituting it in, plugging it in to answer more of the problem. And make sure that your answer makes sense in the real world context. Last one. Chloe opens a savings account with $75 and deposits $40 a month. Juan opens an account with $50 and also deposits $40 each month. Will they have the same amount in their account at some point? If so, after how many months? Write an equation to help solve the problem. Okay, so we want to know, when will Chloe equal Juan? Well, let's write an expression to represent Chloe. Chloe has $75 in her account, plus she's adding $40 a month, per month. So we're going to let x equal the number of months she's depositing money. So $40 a month, and we're going to write Juan as he puts in only $50, but he's also adding $40 a month. When will they be equal? When will they have the same amount of money? Let's eliminate our variable terms over here and on the right. Does 50 equal 75? No. This is a no solution problem. And what that means is there is no amount of months that can go by where Juan and Chloe will ever have the same amount of money in their bank account, because they're depositing the same amount each month. But since Chloe put in more at first, she will always have more money than Juan. And that's it. Let's go try some on our own.